I'm so excited to be here. It's my very, very first Spring I.O. Who else is the first one? Yes, I told you I'm not alone.
Yep.
So I'm also not alone here on stage, and we're going to present on comparing agentic AI frameworks. And we will first look into a bit of the concept, like what is an AI framework, like what is an agentic AI framework. We will not cover so much of the basic about the AI frameworks itself, since we do have another session. We already gave a bunch of other sessions for those. I think they're also here, and also you can find them later. We have linked them. So first, some introduction on agentic AI frameworks, and then we're going to dive into a bit of code. So we have built the same sample with Spring AI, with LangChain4j, and with Embabel.
Yeah.
I think that's the correct way how to pronounce it. And yeah, I'm very excited to be here. As I said, we also compare those three. Obviously, it's based on our user experience, right? So it's how we feel about it. And yeah, we'll show this, so it should be pretty open. My name is Sandra Ahlgrimm. I work for, or I'm the main responsible person for developer experience on GitHub Copilot as well as Microsoft Foundry. So I work for GitHub at Microsoft, and I'm here with Timo.
My name is Timo. I'm working for Broadcom. In my job, I'm trying to help my customers be successful with our products like Spring, RabbitMQ, Bitnami, and Tensor Platform.
Great. So first, let's talk a bit about the glossaries. So first off, a prompt is whatever we put into our machine with the LLM, so a large language model or a small language model, and then there we do have our tokens inside. A token is just a subset of characters, so it can be a single character or a word. So whenever you work with AI, what you get back is just the next token, right? So very limited abilities in terms of, it feels like it would actually think, but then always keep in mind, it's just statistics. It's based on the most likely next token. That's what you get. So for instance, I put in Barcelona is, and then the next token will be vibrant here. Each LLM or small language models has its context size, context length. So whenever I work with something, I feel most of you have already experienced the token limits, right? Yes, the most hands up. So that's what it is, right? So when I have my LLM, you also see that the more expensive ones usually have the bigger context size, so they can keep in mind more things. If that's actually good for our business use case, another question, but that's where it's coming from. And then there are multiple patterns that we can use, and architectures such as RAG, so retrieval augmented generation, is built on, because I can't put it all in the context, I will first, I'm actually enlarging my context. So my LLM is already pre-trained. All the models are pre-trained by the model, by the companies building them, and then they're hosted somewhere. And if I want to enrich the data, I can use something like RAG. So I will basically put in my business context, my business data. It will be put into a
Vector store,
and then based on, and then the context gets enriched, and then I can also retrieve the data from there. And that's how I make it possible that based on my business data, I get the relevant results. Very important whenever we're talking business, since, when I'm a car manufacturer and the customer is asking what's the best car, obviously I want my car and not anything else, right? And then if I need up-to-date information, I use something like tools, so tool calling, like for instance, where I'm currently, what's the season, or what's the weather. When I need up-to-date data, I would use tools for this.
One note here, tool calling is at the end more or less the foundation of most of the features we see with AI agents, so it's a pretty interesting and powerful capability of large language models.
Yeah. So we started with the standalone LLMs, where like 2 years ago, everyone was like talking about prompt engineering and how we can fine-tune our apps, where we just, kind of automated natural language tasks. So I would say, like, give me a summary, give me a bullet point list, or write my emails. Best feature ever, right? Write my emails in a very nice American way, not the German straight way. Really saved my life at work. And then we moved forward with the RAG, as I already explained, where we had the vector DBs and embeddings to get into the business data and retrieve less hallucination. Then, as Timo already mentioned, next big step was the tool using models, so we can call the tools and use them. Next step right up would be the multimodal models, where I can have one model which can do multiple things, like generating images, also giving me the text, and also the speech or audio in and output. Which brings us to the last step, which would be the agentic AI systems, where you can, using MCP, you can do orchestration, use memory, so you really have the end-to-end automation, what we will explain more now. But first, what was needed to get there was the MCP. So when we had the whole agents thing and tool calling and everything was there, and then we kind of needed something like a baseline how to talk to each other, and that's when Anthropic came up with the Model Context Protocol, which was really like the needed step, especially as a Java developer where I'm used to standardizations. We needed some sort of protocol here, even though one might argue if it's a real protocol anyhow. So that's the step here. And then Google came up with the agent-to-agent protocol that allows like AI agents to speak to themselves by determining themselves whom to speak to. And this was given to the Linux Foundation. Okay.
Perfect. Yep,
It's me.
it's me.
No, it's you.
Okay. So maybe I can start. So thank you for all the different topics. Hopefully you're able to understand now a little bit more what we're focusing on here. At the end, we're focusing on agentic AI. So what's the difference to the traditional generative AI applications we built in the past? There, the application was responsible for guiding most of the interactions with a large language model, deciding which tools to use, whether to use retrieval augmented generation or not. The difference to agentic AI is that a lot of this deciding which tools to use is in the responsibility of the large language model. So we're giving the large language model a lot of power in deciding which capabilities it needs to fulfill a task. And in agentic AI, the idea is, as we already saw, that you not only have one agent making the decision, so attaching a lot of tools to a large language model, also at the end having multiple agents specializing on specific aspects and connecting them. And with that, you can imagine for those people that, for example, use OpenClaw, what's possible. So I think we cannot imagine what's possible or will be possible in the future. Before we start comparing frameworks for agentic AI, we first have to learn about what types of agentic AI or agents we actually have, because that's a huge focus. In general, a lot of the concepts you will hear about, they are based on those people that are really on the forefront. So usually the providers or implementers of all those AI models, Anthropic, for example, OpenAI, Google, because they at first I think see the limitations, and then also because they are the implementations or the trainers of those big models, they have the control to add new functionalities, I think, a lot sooner than other companies. And at the end, it's all about limitations. So if we have a large language model, of course, with tool calling, we can attach 100 tools. With MCP servers, for example, from GitHub, another from Jira, etc., we have hundreds of tools. The thing is that we have this limited context size, and the tokens that you send to the large language model are not only limited by this context size, so the amount of tokens an application can accept per request. Also, on the other side, tokens are the currency of AI. So it's at the end, it's the price is per token, which means you shouldn't send hundreds or thousands of tool calls every time, or the metadata for that, to your large language model. And therefore, there are a lot of concepts to mitigate that, and we will see some of them today. And one of the fundamentals about it is also how you actually implement your AI agents. And there are two currently ways. So they are coming, especially this workflow one, also an idea from Anthropic, that you still control a lot of the process of a specific task via code, instead of letting large language model decide it. And those are the workflows. So the benefit is they are predictable. They are more or less in code. And then you have the specific paths, you have specific patterns to actually then start your agents doing a specific task that's really limited in a way, because we also learned that as more concrete the task is, the better the goal. And then there are things like goal-oriented processes, etc., to really get to that what you want. On the other side, of course, if you put everything into the large language model, or let the large language model decide what to do next, and really give him all the flexibility, the benefit for you is at the end that it can handle a lot of tasks you, for example, maybe don't have the tools for, something you didn't implement yet. So it provides you a lot more flexibility, but as said, with a lot of risk also, that you will get something maybe you didn't expect, and especially on the enterprise side, you can imagine that's also something from a security perspective not optimal. Here's some of the workflow patterns. As said, they are coming from Anthropic, like the initial definition. Of course, that's nothing like completely new, but yeah, they write a nice blog article about that. And the easiest, of course, is prompt chaining. So instead of putting everything you want in one big prompt, that you split it, and then it will be sequentially executed. So step by step, that you always see, okay, this is the output, I validate it, send it to the next step. The other one is parallelization, of course. If you want to do like a more complex task, and all those different steps, they don't depend on each other or agents, you can parallelize them. Another one is routing, that you, for example, if you have specialized agents with special models, for example, or special prompts, that based on specific criteria, you send like a request to one agent and then to another one. Orchestrator workers are a way to actually let, in a way, or involve the large language model in the planning, stripping down a bigger task into smaller tasks, and orchestrate it to other models. And then this is also why there's an image for that. I think something really already usable and valuable is the evaluator optimizer. The idea is that if you send a request to a large language model, often you get a lot of like hallucinations, especially if you're not like have those big models with, for example, what we need for enterprise development, things like structured output, that you want to have a JSON response, the JSON is invalid, all those things. You have to resend it. Of course, you can also do that with, for example, Spring Retry and things like that. But wouldn't it be better if it's not just like easy things like the JSON is incorrect, to ask a large language model about that? And there are special models that are better than others in doing the evaluation. So at the end, you get a response. You have another language model evaluating the response. If it's not valid, it will rerun the same call, and do that, like you can define, of course, a maximum, as long as there is no valid result. And if there's a valid result, you will get it back. Of course, this can take some time, but it's really powerful. And for those that are already using Spring AI, for example, that's heavily used within like internal components. Like, for example, structured output, doing those loops for you to always resend it there.
Okay, and with that, it's time to have a look at our sample app. So I love to use conferences to solve my real-life problems, so especially the demo apps. So in the previous versions, we already created a recipe finder, so it would generate I don't know what to eat, and then I want to know what I have in the fridge, and then it should generate the recipe because I really can't cook, but I can follow recipes. That was the idea of the first one, but now I need to go one step ahead and do a weekly plan. And since I have kids, I need to also take care of nutrition, and then it should have, for instance, my profile. So we added a login, so I can sign in here. And
maybe you have to refresh.
Yeah, maybe I have to refresh. Okay. I love live coding. Okay, so I log in, then I get my user profile, and serialize, or in parallel, we should also get what's the seasonal ingredients, so where am I currently, because, based where I'm at the globe, it's different. And then I can do the login again, since we lost this. Oh, Okay, so now I'm logged in. You can see here this one is the LangChain4j one, but we will not show everything since I keep the DE, since I heard we have mostly Germans in the room, maybe. Okay, and then it will generate the plan, and the way it does it is we get first what are the seasonal ingredients as well as other agents we are starting, and then we go into the validation, which will call the generate weekly plan, like in a loop, get the output of the other agents, and then it will generate my weekly plan based on what I have, for instance, in my fridge with tool calling, what's the season, what is my preferences that I might have put into the additional instructions, and then at the end, I should get my weekly plan outputted. Yeah, so here we have it for 2 days already. So here's my Monday plan and the Tuesday plan, for instance, pretty straightforward.
One note here, it looks like, okay, that's something I can do with one prompt, of course. But the thing here is the validation. So it's like we have those user profiles. If there are allergies, etc., that's like in the code, in this case mocked. It will do the evaluation, maximum calories based on this evaluation loop. So it could be that it takes 10 large language model calls to get to a result. Because, yeah, in this case, it's important for us if we care about our nutrition and, yeah.
Yeah, it really helps me also to streamline all the voices in my head, which is like, can I do noodles again? Oh no, the nutrition facts won't be good enough. So I was really happy to have this out of my head and in a good workflow present. Okay. Yep.
Okay. Yeah.
Yeah, that's the next one. Okay.
Yeah.
So
yeah, let's now have a look. Sandra already mentioned what we will have a look today. So we are comparing 3 frameworks related to agentic AI capabilities. As she said, we have a similar talk which is focusing on the core capabilities of those frameworks. First one, Spring AI, enterprise support by Broadcom, was founded in 2023. The next version is the 2.0, which will be released in May. With that, we will get a lot of new features and Spring Boot 4 support, which is, of course, amazing. And yeah, that's about Spring AI.
Yeah, and LangChain4j was the first AI framework for Java developers, initiated by a single person, then presented at Davos, I think, 2023. Very quickly, major companies such as Google and Microsoft, also IBM, Red Hat, put their effort on this one. So very community-driven. Now the inventor got hired by Red Hat, so it's now a bit more under the IBM umbrella. You can also see this with a lot of things first being implemented in Quarkyverse, then maybe coming into LangChain4j later. But I like the fact that it's framework agnostic. I can use it with whatever Java I want, even though being at Microsoft, having a bit of access of what's used in Microsoft Foundry and who's using LangChain4j, obviously it's 80% Spring. It's there to be built also with Spring, and why not? And I'm super happy to finally sneak it into Spring IO because I tried multiple times, and this year was the first one being accepted.
Perfect. So next one is Embabel. It's a framework really providing a high abstraction with all those patterns we saw. So that's the focus of the framework. It's actually founded by one of the creators of Spring, Rod Johnson, who's also here. So feel free to reach out to him. And actually, this framework is built on Spring AI. So it's using all the abstractions from Spring AI, but putting an abstraction on top. Of course, there are more Agentic AI frameworks for Java, for example, Cook from JetBrains. This will be the next talk in this room. So if you are interested in Cook and see how it compares to the others, feel free to just stay in the room.
Okay.
Before we finally jump into the code, we have to talk about some concepts. And as said, every of those frameworks, they're handling how they implement those different agentic AI patterns in different ways. Spring AI, already from, I would say, that the initial version is coming with the so-called advisor API. For those that are not familiar or too familiar with AI, or large language models or AI providers, at the end, all those calls that you do to the large language models are to a REST API, which means that, of course, you can use the capabilities of any framework of your tools, curl, etc., to interact with those models. And of course, it made a lot of sense also from a Spring AI perspective to use the same context, the same experience that we know, for example, from REST client, because it's also for REST calls, it's just some wrapper around it. And what you, I think, already did in the last 10 years and longer is like intercepting REST calls. And that's more or less what the advisor API is doing. So you can intercept at every step of the call and the chain to the large language model for the request and the response and add functionality. A good example is retrieval augmented generation, where you add additional context to your prompt. And that's something in Spring implemented with, for example, the naive one question answer advisor. That all this flow, like reaching out to the embedding model, to the vector store, getting the data back, that's all completely abstracted away via this advisor. And the great thing is, it's not only for built-in functionality. You can more or less build everything with that you can imagine. Okay, the screen will go off, but yeah. And there's another concept, a new one, which is called a recursive advisor. And what's special about that is that you can copy the chain in a way, so what's downstream. And with that, you really are able to enable those, for example, evaluation loops, etc., so that you can add some logic as a specific place and then run those calls and validate them, run them again until you reach to a specific goal, and then the next one in the or behind you in the call chain will be called. So that's really an amazing and impressive functionality. And as said, there are already some of them implemented in Spring AI, like, for example, the structured output validator, or also a tool call advisor that's in addition to the tool calling that you have natively, with some benefits that it can, from observability perspective, etc., incorporate in this full advisor chain. So now it's finally time for some code. As Sandra mentioned, at the end it's like we built this sample with all three frameworks, and we tried to do that in the same way. So the samples are pretty similar, and I will only show the relevant classes here, because of course it's a simple demo app, but it's a demo app, so there are a lot of the main classes, etc., that don't have any relevant logic. In this case, if you're familiar with Spring AI, you should be really be familiar with the code I show you here. The thing is, Spring AI provides a lot of capabilities for Agentic AI, MCP server support, for example, tool calling, of course, a lot of things that are actually on, I would say, experimental supported, so on Git repositories. There are also a lot of blogs about that available. Therefore, it's not like that you have an additional higher abstraction for those different capabilities, at least not until the next version of Spring AI. We will introduce some more of those advisors that do more advanced capabilities, like, for example, what you will hear, tool search. That's one that you don't expose all the tools. You have a tool that says, hey, if you would need a tool, call me, and then I will expose relevant tools to you to actually say, for example, token size. And if we have a look at the implementation here, if you may remember the diagram that we had, the first thing we do here is that we want to start a workflow. So we want to have a parallel one. We want to fetch the user profile and the ingredients, because they don't need any inputs from each other. And that's something I completely built at the end manually, because we have everything for that in Java. So you don't need something special. It's just like running two things in parallel. Yeah. It's just like, as you see, how you would implement it in standard Java running two processes. But that's what I've mentioned. With all the tools you have, you can more or less implement any of those workflows. You just have to do it yourself, as long as it's not production or enterprise ready available from the Spring AI team. But let's have a look at something more interesting. So you can see we have this parallel workflow, and then it will get interesting because now we have this loop. And We then can also see the Agentic AI or the interactions with large language model here with the chat client, this free-end API from Spring AI. As said, if you're interested in that, I think there are a lot of other talks about Spring AI and introducing the capabilities. But the interesting thing is really here. So that's like this loop, as I said, and it's only implemented via this one advisor that I created. So a recursive advisor. That's something I implemented. I also implemented in a way that if you want to try it yourself at home with a different project, it's relatively generic, so you can use it. You see some default instructions. What you want, please create me the meal plan with some here structured output. And then if I have a closer look at how that's actually implemented, we can see it really looks like the example I showed. So we have this advice call, we have like intercepting there, doing this call, and then running a validation whether the response from the large language model is actually valid. And that's something I provided as a function. So there is another large language model call via the chat client API. And then at the end, if it's valid, I will just return the response from the chain. So at the end, then it's like, fine, I will get my result. If it's not valid, I will do, and that's the magic of this recursive advisor, as I mentioned, that you copy the chain and being able to run this loop again. And you do that as long as actually this condition here is true. And you can see I have some default props. Please revise the response. I'm adding this responses then again and again with this validation feedback, and therefore I have a completely generic validation loop implemented within Spring AI. The code is available, so you can have a look. And at the end, that's more or less it, what I want to show here. So it's like, with Spring AI capabilities, tool calling, etc., it's possible to implement most of the current capabilities. My colleagues like Christian, they have blog posts available to do, for example, AI skills with those advisors, etc. So it's really powerful. Feel free to have a look at those examples to be better, like able to see what you can achieve maybe with those capabilities. And as that, the team will work on providing more and more of those production enterprise-ready advisors. Okay. Let's move on.
Yeah, so Mario Fusco from IBM Red Hat introduced the LangChain4j agentic module. As you've seen, Timo had to create the code himself, and Mario thought it would be cool to have this abstraction already in LangChain4j available. So he introduced that module, and we're using it here. So, agents could be defined as AI services with the add agents, and here we are going to use the same thing. So, like, first we had to introduce the interface with the nutrition planner, and then we have here the add agent with the output key and description. And as a Spring developer, I felt some namings were a bit interesting. So for here, we have this add v for ingredients, which is like implementing this agentic way of things. So yeah, so first we have here the create meal plan, where we get all the ingredients, for instance. And then we had to use the agent builder patterns again. So we would get them from our class, and then add the chat module and build the things. And what I love here is that we can mix and match. So like with the agentic services, I can use the sequence builder, put in the nutrition planner, and then add my sub-agents, such as the ones to get the seasonal ingredients or the weekly plan creator or the validation loop. I create them first, and then I can just add them like that. So that was pretty simple in the code. So why don't we have a look? Yeah, code is next. Great. So here are the agents, and just for simplicity, we put them all in the same class. Obviously, first I coded it differently, but to show it here easier, that's how we did it. So here's my interface. where I can put everything in here. And you can also see here is the LangChain4j imports with the V service. So here I have my user profile, the request, month, country, for instance. And then here you can obviously have your prompts in a different folder as a different file. But just for simplicity, we have it here, where you have your user message, the agents, and then here you basically define how the interface for your agents are looking like in order to use them in the way here. So here we first define our different agents, like the seasonal ingredient agents, with the things we just have seen in the interfaces. And then when it becomes interesting is how we add tools, which is the .tools thing, added the weekly plan here, so it has it attached and can then do the loop in the next one, here in the validation loop, where we can then, define how many iterations I want to have, because always keep in mind, it's a workflow, it's consuming tokens, so I would want to make sure that it's useful, right? I don't want to use AI just because I want to have like my defined work stream or workflow, how to use things. So here I defined it should just go 3 iterations. If it's fine with the nutrition, it's good, but otherwise, have an end defined. That's the lessons learned hard way for me here. So here also I have the exit condition. So if it's good, it can also stop doing it. So once the validation is done. And then here, the real magic is how I do the sequence builder here. So first I want what's the seasonal ingredients, right? They have to wait for the other output. And just as a thing, so LangChain4j provides so many more agentic patterns already. I think Mario implemented like everything that's possible, almost. We just used here the ones that were useful for our use case. So that's why we have only implemented those. And then here it's building it, and then it will basically just give me the nutrition plan back here as that. Pretty simple.
Okay, so we saw Spring AI providing all the capabilities, of course, to build those patterns, but not yet providing like too much out of the box of those workflows, patterns, for example, or more advanced tools. They are all like experimental available, but not yet a GA. But there's more at the end. So after large language model already providing high abstraction, there is even high abstraction provided by Embabel, which is really focusing on all those patterns. So there's a lot of effort put in how to best design such a framework. And it's focused on some core concepts. So really the planning is a huge focus. And you can see that even there's no large language model used for that, there's a star search, so also an AI search algorithm used for the planning. And the planning will be done after every step, so we'll adjust based on the output, which will, of course, help with, for example, validation loops, etc. And also then at the end, as said, it's defined really on this goal planning. We have different type of annotations or objects, like, for example, goals or conditions. And another thing is really that it's focused on the domain model. So here, it's a lot about the underlying, I'd say, platform of the framework, deciding what's next, how the different domain models are connected, etc. It's, for example, also possible to, with structured output, etc., to define something based on really the domain models you're sending to the model and getting back, to do also a lot of orchestration, for example, Spring AI, just leveraging at the end large language models. And let's have a look at the sample, and you will see it's completely different to the others. Not from how it's implemented, but how it looks. At the end, the first thing is that I also have annotations to define an agent. An agent is, at the end, here also the concept of running multiple steps. Of course, it's possible to have sub-agents, so you can also then more split those if you'd like to. And then we have different concepts. You see, for example, here's an action. So that's the fetch user profile. And at the end, the name is a little bit strange because of the fact that I also expose an MCP server from here, and there is no user input, so therefore I had to create 2 different methods. But it's like the only thing how I connect those different methods is by the input. You can see the input here is user. The user is available in my case because you saw the login, so it will be sent via just like my UI or the REST controller. Then the next thing is, for example, I see the fetch seasonal ingredients. There the input is a weekly plan request, which is I also get from the user. The AI is just the interaction, so an abstraction on top of the chat client at the end or the capabilities of Spring AI to interact with models or initiate large language interactions. Which means that this planning I mentioned will be done with a star search is actually then deciding based on those inputs whether they are available, what's the next step. And because I have the input for the weekly plan request, it will fetch the seasonal ingredients and return them. And you can also see the output type here. So if we scroll down, we can see now we have the weekly plan request, we have the seasonal ingredients, we have the user profile, so it can execute the step. If it would be like not possible, so there's something missing and there is no step that can provide that, at the end, you will get an exception that the agent was not able to find the next step. And with that, at the end, we are also able to implement those really more advanced patterns. The thing here is if I have a loop, there's an additional concept because at the end I maybe need an additional input, for example, because I have this validation. And on the other side, I want to run that again and again. How can the agent decide? Because it's always like, okay, I have those three inputs. I need them again. How should the agent decide where to go? And for that, we have these states. And the states is something where you can then, for example, define agents in those different stages. Like here, for example, return new revised plan. This will rerun the step. But if I have done weekly, it will go to this one here, to this state, at the end with done weekly. So you have an additional abstraction to, in a way, add additional information, also for conditions, etc., to decide or run those different loops, etc. And it also has the concept of personas, so everything you may know, like, okay, then there was this article about, okay, you can get a lot of better results if you define personas into your prompt. So I'm a nutrition expert and stuff like that. And that's all what, by this high abstraction, is actually provided out of the box. We can see that if I scroll up a little bit with prompt elements, for example, persona recipe curator, that's just an additional prompt, but has a persona name. And we can, for example, also based on that, decide between different large language models, etc., that are used. Another important thing I want to show, and it shows like how much it's oriented around all those different articles about how to build agentic AI or agents at the end, is that if we go to the weekly plan here, we can see that there's, for example, an unfolding tool. This is what I already mentioned. At the end, I don't want to send hundreds of tools to my large language model because all of them have metadata that will be sent to the large language model, reducing my content size, and at the end, it's also like a lot of tokens that will be consumed. So the idea of that is a little bit different to like this search tool, which I mentioned, which is will be implemented also by Spring AI. The idea here is really also that you only provide one tool to the large language model or multiples on this high abstraction. Like here, maybe provide a prompt that it should provide different categories, based on which then you only select tools that are relevant and send that back. And with that, you can save a lot of tokens because you're not sending all the tools, and you also have a lot more control which tools should be called for which purpose. And in the end, for those people that are asking, like, okay, how does it work? How do you initiate it? There are multiple ways, also depending on how you interact with this. This here is a web application and also available as an MVP server. It's also available as a shell to build your like Claude code or something like that yourself. But for this interaction with the controller, at the end, you're building this agent invocation. And just like for this return type, the weekly plan, which is the return type of my agent in this case, and then I'm adding the inputs that I get from the user. And the thing is also for this initiation, of this agent flow, at the end, there's an AI involved finding like those agents that are relevant for those input to start them and then run through. Okay. That's it, actually, about those three examples. As said, they are all available as code. Feel free to have a look to see the differences and experiment yourself. Sandra already mentioned, this is just like current state, and also the colors, etc., don't really reflect like, okay, it's perfect, and the other one is like, room for improvement. It's really current state. For example, for Spring AI, with the next version, several of those capabilities will be provided, but also, as said, the focus is a different focus of Spring AI. It's more about providing those core patterns than like providing this high abstraction than Embabel, for example, where it's really about like, okay, I want to orchestrate those agents and shouldn't care about like those lower levels of abstraction. So that, of course, gives you a little bit less control in what you want to do or flexibility, but helps you probably with achieving your goal a little bit faster. If we have a look at those capabilities, of course, they are not complete. So that's just like what we saw, what most of them actually provide. We saw a lot like focus here on the deterministic workflow. One of those reasons is also because that's one of the most mature ones. Others, like, for example, AI skills. So there's a lot of experimentation on that. And yeah, it runs. But of course, if you would run that on multiple environments, operating systems, etc., as it will run maybe script in this environment. I'm not sure whether that's really production ready. It's just like it works, it's possible. And for example, a huge, innovation driver will be also this human in the loop, so that the agent is able to get back to you to get some additional feedback. You know that, for example, from Claude Code, it's running, then it's like, oh, I need some more information. Also from Copilot, of course. Sorry for that.
No worries. Okay, for LangChain4j, so this one is only for Spring developers meant, right? So this table, since we're at Spring I/O, it makes most sense. So dear Quarkus developers, don't get offended. I know in Quarkiverse they do have the HTTP server support also for LangChain4j, but here we're at Spring I/O. That's why we're focusing on Spring. And also documentation-wise, it means like as a Spring developer, I don't see as much documentation as, for instance, for the agentic AI workflows as for Embabel. For instance, that's how we came up with the colors. It's a community-driven thing. For me as a Spring developer, LangChain4j is still an ease of use. You just have to keep in mind, for instance, if you add your business or your company's features, such as we did with like my boss, Julian Dubois, he added the official OpenAI SDK also to LangChain4j. He forgot to build the Spring Boot starter for it, so I did that yesterday. It got merged. So with the next release, we also get the auto configuration for the official OpenAI SDK to be using as a Spring developer. So for our app, you see it on GitHub. I had to do the configuration myself, which was a bit of a, why? Obviously, when I look at Spring AI, they will always have the Spring Boot starters in place since it's like Spring first. So that's basically the difference here. But we do have the abstraction layer ahead. As I said, we do have the agentic patterns already implemented. I can use them also with all the cool things that Spring provides for me, like the profiles, for instance, we use a lot when we switch between the different model providers. By the way, I also used Ollama for this. It doesn't work as good on GitHub code spaces, but very good on Mac now, since they enhanced, the model speed here, so you can try this out totally also on your own machines if just bring a bit of time, since each LLM call will add some time. So we have seen it in the start that it takes like a minute or two to get the result, and for Ollama it's like 2 minutes more or less. Yep, and I think that's mainly it.
Last but not least, Embabel. As said, it's like 100% focused on those patterns. Therefore, it of course implements all of them. Also noting is that Embabel is not GA yet, which means they can like innovate a lot faster than, for example, Spring AI, which is under enterprise support. So we have focused a lot on bug fixes, etc., not only like trying the latest and greatest. Even if like my Spring AI colleagues, they are like, if there's a new article for Anthropic, like a few days later, they have a prototype of how to implement it in Spring AI. Embabel here of course, even if it's true, everything is green, it has everything, but for example, the AI skills was just added with the release. I think it was released yesterday or the day ago, the first version. As said, because it's a little bit critical, it will run code in the container in a way, because AI skills are about scripts that you have, instructions, and yeah, therefore I think it's also from a security perspective something it's nice to use for testing, but not sure whether for production it's the best idea to directly run that. Oh. And yeah, I think that's it. Here, just like to reference for those people that didn't have the chance to have a closer look at Spring AI, or a comparison of Spring AI and Langchain4j, so the core features. Those are 2 talks we have, and of course there are the demos and the slides in GitHub, so you can also have a look. Those are both focusing on this recipe finder, so grading recipes, showing retrieval augmented generation, tool calling, and those things. Sandra has also those apps running.
So if you need a weekly planner for the next weeks, you can use them today. Timo already pointed out that it's using my AI token, so don't go too much, but feel free to use it anyhow. And yeah, I will turn it off like tomorrow, just to be sure here.
And last but not least, here's also the QR code for the sample.
Yep, on GitHub.
With like those 3 implementations, of course, we will work on keeping them up to date, even it's probably a lot of effort having like 3 of those frameworks trying to get the latest and greatest in as features.
Since we have like 2 minutes left, we have time for a bit of questions. I bring stickers. Timo has those cool magic cards where you should collect 1 of each Spring speaker.
Yeah, I think we need 40 cards, and then you get a prize. And I know also the new book from my colleague Daniel about like testing with Spring applications. There's also, I think, but those will be provided randomly as far as I remember. Thank you very much. Enjoy the rest of the conference.
Yeah.